So in this video, we're covering Unit 5, Test 1. Let's take a look at the way this first problem would work, all right? Just to get the ball rolling, we'll start off just really quickly, okay? You want to understand the angle that fits each description. And one of the most important things is to understand that these lines are parallel and that we classify these angles relative to the parallel lines and this other line that crosses them called the transversal, okay? So I think we know the definition. Parallel lines are lines that never cross, okay? They never touch each other. But one thing that we have to understand is that corresponding angles have to be equal with parallel lines. So corresponding means in the same relative location, all right? In the same relative position is the way that I like to define corresponding. In the same relative position or location. All right, so relative position, not the same position, but the same relative position, right? So what I would say is that 5 is on the top left, okay, and 1 is over here on the top left also. So these two angles are corresponding angles with each other, all right? So each of these words defines a relationship between two angles, all right? So the alternate interior angle with 4, okay, would be 6 over here. Okay, so those are the ones that we call alternate interior angles, all right? We talked about it today during class how 3 is alternate. It's on the other side from 4, but it's also interior, right? So some people might want to say that 3 is alternate interior, but that's also is going to be incorrect because in this case, to really be an alternate interior angle, they should not be adjacent to each other, okay? So in this case, 3 would not be an alternate interior angle, all right? Again, alternate interior angles cannot be next to each other, all right? The next one we got is the same side interior angles, all right? So if we take a look at that, same side exterior angles, all right? Exterior means outside, right? And we can see that 8 is outside of the parallel lines. So which other side is exterior but on the same side of the transversal? Okay, that's what the same side part means. Or alternate. Those two things are helping us understand relative to the transversal, where are we? Alright? So we have angle 8 and angle 4. Alright? Those would be corresponding. Okay? Not same side exterior. Notice how 8 is exterior, it's outside the parallel lines, but 4 is interior. So that's not going to work. Alright? Same side exterior angles would be both of them is exterior, right? So in this case it would be 8 and 1 is our only other option there. So there we go. Okay, this little section is done, and as I was trying to tell you guys earlier today, when we do parallel lines, this is the big idea, okay? You need to understand this picture, and this picture has to be true as long as we have two lines that are parallel, okay? This picture contains all of the knowledge that we need, okay? It lets you recognize whether or not an angle pair will add up to 180 or will they be equal. All right, so if you just take a look at this picture, you should be able to figure out what relationship you need. All right. Let's move down a little bit. As we get farther down here, we find another one now actually talking about the size of angles. All right, so in this problem, we need to actually write some numbers. Let's go take a look. All right, we have two parallel lines, and we have a 97-degree angle here in this spot. Okay. So our basic definition of parallel lines now in geometry basically means that these are lines where if they have a transversal, the corresponding angles with their transversal must be equal. All right, so in this case, this means A must be 97. Okay, we would call those corresponding angles. All right, but what about for B? Okay, for B, we take a look at this one and we say, well, okay, A is 97, so I could go label my picture. But now what you want to be able to notice is that these two angles are adjacent and they form a linear pair. So that means that they have to add up to 180, right? So we should have on this side right here is going to be, angle B is going to be equal to 180 minus 97. So you should have 83 degrees for that. Okay, so B we go put 83. And now we got to make a choice for angle C. And I'm hoping by now at this point of the year you guys do know that vertical angles are something we should be able to do in 1 second. And so we see these two lines cross. And so I should be able to see that this angle and that angle, they have to be equal. All right, so this would be 97 right there. All right. Another way to think about this angle C would be that it's an alternate exterior angle with that one, and the alternate exterior angles would have to be equal also. All right. So we had B right here. This one formed a linear pair. And in this case, these were alternate exterior angles. And so that'll help you figure out what you're doing. All right. So again, those angle pair relationships you can figure out just by looking at one of those drawings that we drew with everything just being equal to 80 or 100. So now with this next step, let's scroll down a little bit and see the rest of the test. So in this case, we have to write an equation and solve for x, okay? And as I told you guys, we wanted to be able to see this picture, and we wanted to know that all of the information that we need is contained inside of this one little picture. Okay, so if I was you, I would jot that down on the middle of a test just to make sure that you don't do something, a little mistake, all right? We can see that we have these two angles that are on the inside, and they're on the same side of that transversal. So again, we call those same side interior angles. And as we can see here, I can tell, look, these two numbers are not the same number, right? 100 is not equal to 80. So this would be the one where they have to add up to 180. So the equation I would write would be x plus 129 plus the other angle, right? X plus 59. Okay, this has to be equal to 180 degrees. And then we would just go through and solve it. So we got x plus x is 2x. And then 129 plus 59 makes us 170. All right. 198. No. Sorry, 188. Okay, then we take 188 from both sides. After I do that, we get 2x equals negative 8. Okay, and then if we solve through, we could divide both sides by 2. And we'll have x is equal to negative 4. Okay, so let's solve through and do the basic algebra. Again, this is something that's going to underlie all the other skills that are going on, so make sure you brush up on that. If you're a little stuck, ask me a question if you can't remember how to do a two-step equation. All right? So we can move on to the next problem right now. So here we go. On this problem, we'll be dealing with the triangle angle sum theorem. And so in this case, we're not doing it purely numerically, right? This time we have some expressions that we have to deal with, all right? So we're expecting you guys as math teachers, right, that you look at this triangle, and that's the main key that helps you solve the problem, right? We know that by looking and seeing the shape of the triangle, that these three got to add up to 180, all right? See you later. So the big idea is we got 35 plus x minus 10 plus 2x plus 5 equals 180, okay? We took the three of those, and we made an expression. We add them all up to 180, basically, okay? So we can combine all of our like terms, all right? I happen to put parentheses in this case just because of the negative sign, and I thought it would be something that we could talk about, all right? But it's not really going to change much when we go simplify this next step. So we could combine our like terms, right? 35 minus 10 is 25, okay? And then 25 plus 5 is 30. So we got 30. Okay, but we also have this x plus 2x. That's going to give me 3 x's, right? So we combined our like terms, all of our x's, as a total of 3x, okay? And as we said, 35 minus 10 gives us 25, and 25 plus 5 gives us 30. So we have now this equation. All right, and if I take 30 away from both sides, then we will have that 3x is equal to 150. All right? So we would then divide both sides by 3. And that tells us that x must be equal to 50. So we have x, and that would be the number that we put in this location. But now, in order to finish the problem, we should go substitute in our x for 50. So we realize that we are plugging that number in for x right there. So 2 times 50 plus 5. Well, 2 times 50 is 100, and 100 plus 5 is 105. Okay? But I also have to plug in this 50. We have to plug that in here too. Okay? So x minus 10, well, 50 minus 10 is 40. So that's what goes here. Okay, so that's really all that happens on this part of the test. We have more examples that we'll look at, but they are essentially the same problem. You just have to understand how to set it up. So again, this problem would be the same way. This would be a great one for you guys to pause and try to figure it out. Even try to figure out how you would do the first step. What would be the first thing that you write? Okay, and the big idea here is that these 3 angles, again, have to add up to 180. So I know I'm going to take these 3 things, and I'm going to write them, and in between them we'll have plus signs, right? I'm going to add these 3 things up, and they will set them equal to 180 degrees. Okay, so the things that go in there are right here, right? 7x minus 11 plus 5x minus 2 plus 2x minus 3. Okay, and again, if we combine all our like terms, so collect all of the x's first, we can see that we have 7x and 7x, so that makes 14x. And then we got negative 11 minus 2, so that's minus 13. And then minus 13 minus 3 would give us minus 16. Okay, and we see that all of that is equal to 180. So now what we would need to do is to basically add 16 to both sides of this equation and solve it. So let's go ahead and do that. Move a little bit of room. So right here, we now can add 16 to both sides, and we will end up with 14x equals 196. If we then go divide both sides by 14, we are going to get that x equals 14. Okay, so now we have that value, and we can plug that in here for x, and we can go substitute the x into these other values likewise and go get what they are. So I'll plug in x right here. Okay, we do 7 times 14, and that's 70 plus 28, so we get 98 minus 11, and 98 minus 11 is going to be 87. Okay, so just little by little, plug in the value and get the next one. We can do the next one too. Okay, 2 times 14, right? Again, we're plugging this 14 in for x right there, right? So this is 2 times 14, which is then 28, and 28 minus 3 is 25. Okay, so there's way more ways to show your work, but again, this is like a quick review video, and I don't want it to run on and on. So again, we saw the issue that happens here on this problem too. All right. As we scroll down, we see that we got a different idea, and this idea of a mid-segment. And so for this problem, the setup is basically everything, and it's this idea that you guys want to understand. We have a similar setup from our inscribed angles problem, actually. Right? The idea is that we need to see that we have similar triangles here, right? Because this is a mid-segment. So what a mid-segment means is that this is the midpoint, right? Q is the midpoint of ST, and so those two sides would be equal. And also, since PQ is the mid-segment, that means that P is that midpoint of this line SR, so those two sides are equal. So what we could see again is like, well, if this is X, right, then this is also X, so that means that this whole side would be X plus X, and that's 2X, all right? But now notice that we just have this little red triangle that we're looking at, okay? Well, if this is Y, then that would be Y. And that would mean that this whole side would be equal to 2y. And so now we can see, wait a minute, we just have similar triangles with side angle side right now, right? Y is getting multiplied by 2. X is getting multiplied by 2. Okay, so the smaller triangle is getting all of its sides multiplied by 2 so that they could become the bigger triangle, right? We have a situation It's kind of like this, right? Where we have a little one and a bigger one. And if I tell you, all right, this is 10, and that the whole thing is 20, right? And I tell you, oh, this is 3, and that this whole thing is 6, and then I tell you, hey, this side is 5. What's that got to be? I mean, well, what do you see happening, right? Do you notice that all the sides of this little triangle are getting multiplied by 2? Because that's the pattern. So then what's 5 times 2? And 5 times 2 is 10. All right, so I hope you guys can see, right? 10 times 2 is 20. 3 times 2 is 6, right? And 5 times 2 is 10. So the idea of a mid-segment is what helps us figure out that we have this value of 2 here. Okay, so what this really tells us is that this outside number, right, 4x minus 27 is equal to 2 times the smaller side, the one that's inside. In this case, the blue part, right? That's x plus 9. And so this is the relationship that has to be true. If we just use the distributive property, then we have a simple little 2-step equation that you can then solve. All right? So again, this all comes from this idea of similar triangles. The only thing is that we didn't really draw the whole triangle for you. We're expecting you guys to kind of decode that part. So we're at this step right here. If I take 2x from both sides, all right, take 2x from the left, take 2x from the right, well, now we're going to have all of our variables on one side, so I'll put the remaining work over here. We have 2x minus 27 equals 18. And now if I just add 27 to both sides, okay, we're looking at something. We got 2x plus, 2x equals 18 plus 27. So if we add that up, we will get 45. Or excuse me. And you might hesitate a little bit, right? Because it doesn't feel right because this number is not an even number, okay? But that can happen sometimes. Everything does not always have to be an even number in the universe, right? So that means that this last step, we divide both sides by 2, and we will get that x is equal to 22.5, all right? Which is something that can happen. So we have our x value, 22.5. And now to get the other values, again, just don't forget to substitute, right? So in this case, we'll do 22.5 plus 9, and that gives me 31.5, okay? So again, just plug in your numbers in here, right? In this case, I'll have to do 4 times 22.5 minus 27, and you have to calculate what that is, right? 4 times 22.5. You can go ahead and work on that on your own and try to get an answer, okay? See what you do. So we get 22.5 times 4, and that's going to give us 90. And so we get 90 minus 27, and this will give us 63. So this is the way you guys should follow this part of the test. There is going to be one video that I still have to make, all right, and that one will be about this part specifically that I'm going to show you right now. Okay, the next test, the next video that has to do with this test is going to cover the proof separately. All right? I want to separate this knowledge. So we'll do the proof in a separate video. Okay, we'll talk about the proof of the vertical angle theorem and this alternate interior angle theorem, and we'll do that in a separate video. Like I said, use this to review everything else for the rest of the test. All right. Good luck.